For example 2, part D, we have 3 terms this time, but the process still is the same. We have x, and then we're going to have to factor this next one. It's a case 1 trinomial, meaning we can just use guess and check. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. The pair that will get me to a -7 using same signs would be the 3 and 4, and both of them should be negative. So the factored form is x minus 3, x minus 4. And for this third term, we have GCF of x. So if I pulled that out, I have x minus 3. That means that the least common denominator would be, first I'm going to list the similarities. So I see that I have x is a similarity between 2 of the terms, and x minus 3 is another similarity, and the difference is x minus 4. For part E, once again, we're going to factor. The first set is a difference of 2 squares, where a is x and b is 2. So the factored form is x plus 2, x minus 2. Next, we have a trinomial that's case 2. I know that because of the 3 that's in front of the x squared. Remember, when we are factoring a case 2 trinomial, you need to multiply those 2 terms together. So I have a -30x squared that I'm going to look at the factors of. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Because it was a -30, I have to use different signs to get me to a -13. So once again, I need to use different signs. My eyes went to the 10 and the 3 right away because that could give me 13, but only if I would have used same signs. So it actually doesn't work. I would have to use a +2 and a -15 to get that -13. So now I'm going to rewrite it as 4 terms. So 3x squared plus 2x minus 15x minus 10. And factor by grouping. The GCF here is x, and I'd be left with 3x plus 2 once I pulled out that GCF. The GCF for the second 2 is a -5, because when I pull out a -5, I would get a +3x and a +2, which is what I wanted. Meaning the factored form is 3x plus 2, x minus 5. Now we can finally identify the least common denominator since we've factored everything out. Well, there's no similarities, is there? So whenever there's no similarities, we need to write all of the different binomials and multiply them together. So it would be x plus 2 times x minus 2 times 3x plus 2 times x minus 5. Okay, part F. This is a monomial. It does not factor any further, but we do have a GCF here of 2. So that would be 2 times x plus 4. For the least common denominator, we can look at the constants first. So we have a similarity of 2 and 2. And we have a difference of x squared and x plus 4. So I'm going to multiply all of those different things together. Oops, sorry, I realized you can't see the last bit right there. Now that I've had you practice identifying the least common denominator, we're going to actually begin adding and subtracting rational expressions that do not start off with a common denominator. Let's take it slow and start with example 3, part A. The first thing that I need to do, and I'm just going to follow these steps right here, okay, is factor the denominator of each term if possible. When I look at a, I have a 3y squared and a 2y. These do not factor any further. Those are just monomials. So I don't have to do the first step. The second step is to identify the least common denominator. Okay, so the least common denominator, the first thing I'm going to do is look at the numbers. I have 3 and 2. Keep in mind, we need to multiply one or both terms by something to get it to equal the same thing. So the multiples of 2 are 2, 4, 6, 8, so on and so forth. The multiples of 3 are 3, 6, 9, 12, 15, so on and so forth. The least common multiple that they have would actually be 6. Notice how I can multiply the 2 by a 3 to get 6 and the 3 by a 2 to get 6. And we also have a variable y. Now, when we're identifying the least common denominator, we actually want to use the largest power. So I should put y squared. The reason why is if I can only multiply by something to get the same denominator, I would have to multiply the y by another y to get y squared. If I would have tried to go from y squared to y, we'd have to divide by y, and we don't want to do that. It's called the least common multiple, or multiplying terms together. Okay, next step. Multiply a term or terms by a ratio equivalent to 1 to get a common denominator. So it's really important that we have a ratio equivalent to 1, because technically when we multiply something by 1, it still has the same value. We're rewriting it, but we're not changing the value of the actual function. So what that looks like is I have x over 3y squared plus 1 over 2y. I need to multiply this first ratio by something to get my 6y squared. So what do I have to multiply 3y squared by to get a 6y squared? Well, we'd have to multiply by 2. But not just 2, 2 over 2. You see how 2 over 2 is technically equivalent to 1? So we're not actually changing the value, we're just going to be rewriting it as 2 times x is 2x, and 2 times 3y squared gives me that 6y squared that I wanted. Now I'm going to have to multiply the second term by a ratio that's equivalent to 1. We need to ask ourselves, what do we multiply 2y by to get 6y squared? Well, 2 times 3 would give me 6, and y times y would give me y squared. So I would have to multiply by 3y over 3y. Remember, when we multiply, we go across the top, across the bottom, so this gives me 1 times 3y, which is 3y, over 6y squared, because 2 times 3 is 6, y times y is y squared. Now that they have a common denominator, we could do the next step, which is to add or subtract. You don't do anything with the denominator, you just leave it over that 6y squared, but we're adding the numerators together. So I have 2x plus 3y. And then we simplify, if at all possible. That would be the last step. The numerator has an x and a y. So because these are different variables, we cannot combine that at all. And you cannot simplify any further. You can't cross off the y's, can't divide the 3 and the 6, or the 2 and the 6, okay, because of this addition sign. It's an expression, meaning that this is our final answer. Next, we have to identify when the function is undefined. In order to do that, we're just going to set the least common denominator equal to 0. So 6y squared equals 0. And then we solve for y. So divide by 6, I get y squared equals 0 divided by 6 is just 0. And then to undo a square, remember we talked about in class, we take the square root. This was a first semester idea. So y equals, the square root of 0 is 0. Technically, whenever we take a square root, we need to put plus or minus out front. But 0 is neither positive nor is it negative. So I can just write that it's undefined when x equals 0. Example 3, part B. This one is a little bit more complex because we have expressions now instead of just monomials. So the first step, once again, is to factor the denominator of each term if possible. The denominator of the first term is a case 1 trinomial, so I can just use guess and check real quick. The factors of 4 are 1 and 4, 2 and 2. It's a negative 4, so I know I'm going to have to use different signs to get a positive 3. So negative 1, positive 4. Okay, so that means I really have x minus 3 over x minus 1, x plus 4, plus 2x over x plus 4. Now, next step, we need to identify the least common denominator. Remember, when doing the least common denominator, we're going to multiply the similarities by the differences. So a similarity they have in the denominator is x plus 4, and a difference is the x minus 1, because this has it, but this does not. Now that we have the least common denominator, we're going to ask ourselves what we have to multiply the terms by in order to get a common denominator. Whatever we multiply should be equivalent to 1. So when I look here, I have x minus 3 over x minus 1, x plus 4. This already has the least common denominator, so I don't have to multiply it by anything. However, the second term only has the x plus 4. It's missing the x minus 1. So I need to multiply by x minus 1 over x minus 1. That means that I have a common denominator now of x minus 1, x plus 4, and I can add the numerators. So I have x minus 3 plus 2x times that x minus 1. Then we want to combine like terms and simplify. The first thing you're going to have to do is distribute the 2x to those terms. So that gives me x minus 3 plus 2x squared minus 2x, all over x minus 1, x plus 4. Let's clean this up a little bit further. I like writing it in standard form, so I have a 2x squared. Combine my x's. 1 minus 2 is a negative 1x, and then minus 3. Okay? Whenever you check to see if you can simplify further, you should see if we can factor this numerator and cross stuff out. Because this is a case 2 trinomial, I'm going to have to look at the factors of negative 6x squared. And it is possible to get a negative 1 using different signs. So that means I have 2x squared plus 2x minus 3x minus 3, or 2x times x plus 1 minus 3 times x plus 1, or x plus 1 times 2x minus 3. I rewrote that into the numerator. Notice how even when I factored it, nothing else cancels, so this is our final answer.